So we need to work out in part A, g f of x. So f of x is e to the 5x. So this then becomes g of e to the power of 5x. And so this is going to become 4 ln e to the 5x. Now, using the power law, this can come to the front. And in this case, it will be through multiplication. So we get 20x ln e. And ln e to the power 1 is 1. So this then becomes 20x for part A. Does that make sense? Are we happy with that? Well, let's have a look. So fg of x is what we've been asked to work out. So that's the same as saying f of 4 ln x. And so I'm going to do e to the 5 times by 4 ln x, which is e to the 20 ln x. But now we're going to use the reverse power law and bring that to the top here. So we get e to the ln x to the power of 20. And e and ln sort of cancel out, so we're left with x to the power of 20. Okay, we can check that here. One thing I should have mentioned here is your domain for part A and part B. Now, if we are substituting x values from f into g, the x values for f can be any real values. That's why this is x can be any real value. Whereas in part B, we are substituting x values from g. And x values in here have to be greater than 0. So that's why we have got x is greater than 0 and x can be an element of reals. So the key thing to take away from this is you have to look at essentially the function inside the brackets, domain of inside brackets. Okay, does that make sense? Are we happy with that? Do you understand where this domain is coming from? Because we inputted g into f, the gx values are any real values as long as x is greater than 0. And that's why the x values for this whole function are x can be any real values as long as x is greater than 0. Right, okay, so just a bit of a recap on yesterday. Next thing that we are going to move on to are inverse functions. Can you please remind me, what is a function? What is a function in the chat? And both of them satisfy something. There's one very important thing. Yeah, one value of x gives you one value of y. That's the key thing here. And that's why the circle is not a function, or positive and negative square root is not a function. and so on. So now, what is an inverse function? Well, inverse function is a reflection of original function in y equals x. So a classic example might be if we think about y, not y, if we said f of x equals e to the x, where x is an element of all real numbers, we get that, we know what that looks like. So that is a function. Every x value is defined. You can substitute any x value. Sort of looks like this shape here. Now, if we think about y equals x, it looks something like this. This is y equals x, and this was, let's call it f of x. If I now reflect, actually I need a couple of more things. I need y equals 0 as an asymptote. Okay, so these are all the things that applied for f of x. Now, if I now look at the inverse of f of x, if I reflect the curve in the dotted line, I get something that looks like that. Now, that y value of 1 now becomes an x value of 1. The asymptote of y equals 0 now becomes x equals 0. So we've now got an asymptote here along that line. Does that make sense? Are we happy with that? And so now this would be defined as the inverse of f of x. Okay, so your original line was f of x, your inverse is the reflection of the original in the line y equals x. Now, what do I want to think about next? How do we work it out? Let's say we had y equals e to the x, and we had to work out the inverse of that. Well, we have to make x the subject. How are we going to make x the subject? We take logs on both sides. We get ln e to the x, x ln e equals ln y, and ln e is 1, so x equals ln y. So we've made x a subject now. Your original f of x was e to the x. Once you've made x a subject, from this, to find the inverse, we are going to replace the y with x and the x with the inverse function. So we get, if we replace the y with x, we get ln x, and if we replace the x with the inverse function, we get that. Okay, so that is how we go from the original function to the inverse. We have to make x a subject and then replace x with inverse and y with x. Right, okay. Now, let's look at something. F of x equals x squared, where x can be any real value. Can you, what does f of x look like? Can you describe to me in the chat what f of x looks like? positive quadratic U shape going through the origin. Okay, so that's good. This is y, this is x. It looks something like that. We know what x squared looks like. Now, how are we going to draw the inverse of this function? So if I call this f of x, how am I going to draw the inverse of this function? Can you please describe it to me in the chat? First, draw the line y equals x, okay? So let's draw that. Let's say something that looks like this. And then what are we doing? Once we've drawn that, what are we doing after that? We're going to reflect the black line in the dotted line. Right, so we get something that, I don't know, something that looks like this. Would we agree with that? So this is the inverse of f of x. Are we happy with that drawing? Now there's a problem with the blue curve. It is not a function anymore. Why is that not a function anymore? There's a big problem with the blue line. It is not a function anymore. Because one x value has many y values. So we can't have that. This is no longer a function. So how do we deal with this scenario? How can we deal with this? This does not, an inverse does not exist. So we can say here, no inverse exists here. Because we get a one-to-many. So what we can do with f of x is we can say, well, we're going to say x squared, where x is greater than or equal to 0. So we're going to make the original function a one-to-one function. And then when we draw a dotted line across it, and then draw our inverse, we get a valid function. Okay, does that make sense? So one key thing you need to understand is for the inverse to exist, for the inverse function to exist, f of x must be what? You tell me. For the inverse function to exist, f of x must be a one-to-one function. Very important. If we have many to one, then it's no longer will an inverse exist. Okay, this is very important. Right, okay. What I'm going to do now is just go back to this and just have a little think about So I've shown you how to actually work out inverse functions. Now the next thing that I want to focus on is domain and range. So f of x was e to the x. And we said x can be an element of real numbers. What's your range for f of x? What is your range for f of x, please? You need to tell me in the chat the range for f of x. Can you describe it a bit better than that, maybe? You're almost right. So what is range? Can you please tell me all real numbers? So you're saying range, what does range refer to? So if we've forgotten something, we just backtrack our way. Keep backtracking until we figure something out. Range refers to what exactly? Well, it refers to y values. If you think about y values, we are looking at the height of the black line because we've sketched f of x. What is the lowest height of the black line? Well, we've got asymptote at y equals 0. So above that, so we can draw a hollow circle there and it goes up forever on that side. So the range is f of x is greater than 0. Would we agree with that? Can you please let me know in the chat? Okay, so your range for f of x is greater than 0. Okay. So we know the domain. This is the domain. And we've got the range underneath. Now, if we consider the inverse function, which was ln x, what is the domain for that? Well, we can see that we can't have x values less than 0. The blue graph does not exist to the left of the y-axis. So the domain is x is greater than 0. And the range, what's the range? Range for the inverse. Can you please tell me the range for the inverse in the chat? Maybe looking at the graph. You can see that it goes to minus infinity down here and it will keep on climbing forever. So we can say f of x can be, f minus 1 of x can be any real number. Does that make sense? Are we happy with that? So what is the conclusion that we can draw from this? I want you to type that in the chat, please. Okay, so range for f of x equals domain for f minus 1 of x and domain for original equals range for the inverse. Okay, that's very important here. sort of like the x values or the y value for the inverse became the x value for the domain. Maybe this is how you might remember it. Because if we write this as a coordinate 0, 1, this now became 1, 0. So your x and y values have swapped around, essentially, is what has happened. Okay, and so that's why your domain and your range flip over. Right, okay. So I'm going to get you to answer some questions on here. One second. Yeah, I'm just going to go back down to that here. Right, can you have a go at h of x equals 2x plus 1 over x minus 2. If x approaches 2, as x approaches 2, the denominator is approaching 0. Does that make sense? Are we happy with that statement there? What happens when you try to divide by 0? You don't get 0. You get undefined. H of x will be undefined. Okay, so what happens is the function approaches 0, there'll be a vertical asymptote. So there's going to be a vertical asymptote at x equals 2. And that's one way of figuring out where your asymptote is going to go. Make the denominator equal to 0. Right, okay, so you've done that. Right, have a go at part B. Maybe work out h of x, h inverse of x first. Do part C first and then plug in the answers to find part B. Right, let's have a look at this. I'm going to do part C like I said first, just so that you can have a look. So, how do we find the inverse of h of x? That's the question mark. Well, I'm going to start off first of all by saying y equals 2x plus 1 over x minus 2. Then I need to make x the subject. If I make x the subject, how am I going to do that? I'm going to have to multiply this across. Yeah, xy minus 2y equals 2x plus 1. And if I want to make x a subject, I'm going to collect all the x's on the left-hand side. Doesn't really matter which side. And now I can make x a subject by factorizing. Or if you collected it on the right-hand side, you might have got minus 1 minus 2y over 2 minus y. So that's fine. Now your inverse function, once you made x the subject, You replace x with the inverse function and you replace y with x. So you get 1 plus 2x over x minus 2. Are we happy with that? Does that make sense? Right, okay, so now that's perfect. So once we've got that, I can now work out inverse of 3 very easily. I just substitute 3 in there. 1 plus 2 times by 3 over 3 minus 2. So we get 7. And that's very good, what you recognize there. What else do you recognize in part D? There's something else you should recognize when you look at this. Now, when do we get a scenario like that? So now you're starting to realize that h of x equals the inverse of h of x. This is known as a self-inverse. And I'm going to show you why that is using an accurate graph. So let's now look at y equals 1 plus 2x over x minus 2. So we can see what this graph looks like. We can see that there is a vertical asymptote at x equals 2. Now, if on this I sketch, if I place a line y equals x on there, when I reflect these curves in the blue line, I get itself. Does that make sense? When I reflect the red line in the blue line, I get exactly what I started off with. And that's why you've got h of x equals the inverse of h of x. It doesn't happen, it's true for sort of reciprocal graphs more so than others, to be fair. Okay, any questions there? So we've been asked to work out the inverse of f of x. So we think about this, y equals 2x squared minus 3, y plus 3 equals 2x squared, x squared equals y plus 3 over 2, and finally x equals y plus 3 over 2 square rooted. Okay, so I've now got this. Now, it said here that x is less than 0 originally. So if x is less than 0, essentially think about it, we are going to take the negative square root, because we're cutting all of this off. This no longer exists. And so if we were to sub in a y value, we would be taking the negative square root. So this should be negative on here. Okay, that's very important for you to understand. Can you just make a note of that? Now, I also asked for domain and range, so I haven't finished doing this. So f minus 1 of x should be the negative square root of x plus 3 over 2. That is how we write this. And we can't have the positive square root because we are looking at to the left of the quadratic curve. Now, domain and range. Well, the easiest thing to do is work out the range. What is the range of f minus 1 of x? That equals domain of the original function. And we've got the domain of the original function. All we are then going to do is say f minus 1 of x can be any real value as long as f minus 1 of x is less than 0. Does that make sense? Can you please let me know in the chat if you are happy with that? Okay, so we've done the range. Now, to work out the domain, I'm going to have to work out the range of this graph. So we're going to say domain of the inverse equals range of the original. Well, how are we going to work out the range of f of x? We sketch it. 2x squared minus 3x squared looks like this. 2x squared looks like this. And then we finally shift it down by 3. Looks like this, but we are only going to consider x values less than 0. So we should have something that looks like this. So what is the range of this graph? Well, lowest it can be is minus 3, but we're not including that. Anything higher. So range of f of x is f of x is greater than minus 3. So therefore, the domain of the inverse is going to become x is greater than minus 3. Does that make sense? Can you please let me know in the chat? Okay, so this is the working out that you're going to be required to do if it does ask for domain and range. I'll literally write statements like that in the exam and then work it out from there. Right, okay. So a few minutes to do part B. Let me know how you get on, please. It's saying values of a for which f of a equals the negative, the inverse. So f of a equals inverse of f of a. Well, we know what this is. This is 2x minus 3. We worked out the inverse earlier. So negative square root of x plus 3 over 2. That's where we're going to start off. It's not asked for the range of values, it's just asked for the values because it's an equation, it's not an inequality. So if I square both sides, 2x minus 3 equals, if I square the right hand side, what am I going to be left with? Well, minus times minus, in fact I should write this out just so that you can see how it plays out. If you're unsure, just do something like this. Minus times minus is positive, the square roots cancel out. Root of something by itself is going to be what's inside the root. So here we get 2x minus 3 squared equals x plus 3 over 2. Are we happy with that? I'm just going to check something. Yeah, no, everything I've done is right. Isn't it meant to be 2x squared? Oh, sorry. What am I doing? Yeah, 2x squared minus 3, yeah. So now I can expand this bracket. 4x to the power of 4 times by, so it's minus 12x squared plus 9 equals x plus 3 over 2. Well, I'm going to get rid of the 2 by multiplying across to the left-hand side. 8x to the power of 4 minus 12x, not 12 anymore, is it? 24x squared plus 18 equals x plus 3. Now if I take everything over to the left-hand side, minus x and plus 15 equals 0. I'll be happy with that, Cortic. Is that what you got when you first did it? Now, at this stage, what can we do? Well, we can put in the calculator and it solves Cortex for us. So menu a polynomial, power 4. If I just move this along a bit, we've got 8, no cubic, so that's going to be 0, so we have to be careful there. Minus 24 minus 1 and positive 15. So I'm getting x equals 3 over 2. X equals 0.896, let's just call it. X equals minus 1. Are there any other solutions? X equals minus 1.40, let's just call it that. Now, in the question, it did say that your x values are less than 0. So I'm guessing that these ones here are not going to be a solution. Check that here. Let's do it again. Minus 1. Why is the other one minus 4.1.4 not included in there? Oh yeah, okay. So they need to be, for the line to be equal to its inverse, would you agree that you've got a dotted line here just to make sense? I'm going to get something like this. For the line to be equal to its inverse, they're only going to meet where if they're on the line y equals x. They have to meet on the line y equals x. So this one here is also not going to be a solution. Because that is not on that point there. So x equals minus 1 is the only one that is going to meet this. I'm going to cover a bit more of this next lesson. We'll call that lesson for now. There's not going to be a lesson tomorrow.